In this Algebra 1 video, we're in Chapter 9, Lessons 1 and 2. We're going to talk about graphing and solving quadratic functions by graphing. Our objective is, as the student, I can graph and solve quadratic functions because I will find the axis of symmetry, and then I'll make and graph an input-output table of values from both sides of the axis of symmetry in order to look to see where the x-intercepts are. Now, that was a lot of words to the objective, but basically that is the core of what we're going to be doing for this whole graphing concept. I hit you with a lot of vocabulary words. Let's make sure we know what they are. First of all, a quadratic function. Nothing too complicated. You've actually been doing them all along without realizing it. We've been doing them for a while. It's a polynomial whose highest exponent is a 2. An example is that. And we've dealt with polynomials like that in our last chapter when we were talking about factoring. The graph of a quadratic function is called a parabola. And that graph will always look like a U. It'll either open upwards or downwards. At a quick glance, you know whether it opens upwards or downwards by looking at the leading coefficient. It's a quick way to know is it open upwards or downwards. So look at this question right here, just the one I made up. It's a positive 3 leading coefficient. Therefore, that parabola will be opening upwards. So that's a test-taking strategy. For example, when you're on the EOC, they'll say, hey, graph this quadratic, but 2 of the answers will be like this. And so you know that those are out because they open downwards. So then you just have to be specific about the other 2. So parabolas open upwards or downwards in general. Now, another set of vocabulary words. All these words mean the same thing down here, so I just kind of put equal signs between them all. If a question says find the solutions, or it says find the roots, or it says find the zeros, or it says find the x-intercepts, all those mean the same thing. Hopefully the one that you definitely know is x-intercepts. In other words, where does it cross the x-axis? And in other words, where does y equal 0? Let me throw out some examples for you. I got 3 possibilities. Take a look at my first example. My first example just happens to be a parabola opening upwards, no big deal. But look, it crosses the x-axis 2 times. This parabola, this curve, it's kind of like a U. It crosses twice. Therefore, we would say it has 2 solutions. Now, you would actually go further and actually find what were the ordered pairs of those solutions, or at least what were the x values of those solutions. But for now, I just want to make sure you know what a solution is. We'll talk about identifying them later. But if it says find the roots, that means the exact same thing. Finding the roots is the same thing as finding the x-intercepts, or the zeros. The word zeros gets its nickname because at the x-intercepts, let's say that's 1, 2, 3, 4, let's say that's a positive 5, y equals 0. That's where it gets its nickname of finding the zeros, because when you find the x-intercepts, y is 0. All right, let's look at another possibility. Another possibility is, that was 2 solutions, let's check out 1 solution. And I'll do a parabola opening downwards just to be arbitrary. It's a parabola opening downwards that touches the x-axis only once. Pretend it was touching right there. It touches it only once. And it's basically kind of like it bounced off of it. Now, that example, because it touches the x-axis only once, that will have one solution. So now you might be thinking, I'm counting down, so you might be able to guess what the next situation is. 0 solutions, meaning imagine a parabola that does not touch the x-axis at all. It comes down, it turns, that one touched. Comes down, it turns away, and never touches the x-axis. Therefore, it has 0 solutions. Okay, so that's what the graph of quadratics looks like. Alright, so we got a few more vocabulary words, but we're now going to focus on how to graph. Now we have an idea of what the graphs look like, but now let's talk about specifically how to graph them relatively accurately. Now, before we do anything about graphing them, let's label a few more parts because these are the parts you want to know in order to graph them. Okay, so you have your axis of symmetry. Now, remember, the word symmetry means it's like a reflection. So imagine someone's face. This is my person. Don't laugh at my drawing. But this person has an axis of symmetry. Well, most people, my person's ugly. Where the left side of their face is a reflection of the right side of their face. That's an example of an axis of symmetry. And specifically for parabolas, that's what I'm talking about. It's a vertical line right down the middle that cuts it into 2 equal halves. That vertical line technically has an equation like all vertical lines, and the equations of all vertical lines is x equals a number. Remember Hoy-Vux. Horizontal lines have a 0 slope and have a equation format of x equals a number. So, anyways, you can find it by using this formula. This formula is the opposite of b divided by 2a. That will tell you the x value of the axis of symmetry. And as a heads up, that'll also tell you the vertex, but we'll talk about that. So anyway, this b and a nonsense, it's the same thing we've already talked about when we were talking about factoring. The whole ax squared plus bx plus c, that is the standard format of quadratics. Kind of like y equals mx plus b is the standard format for lines. This is the standard format for quadratics. So when I say b, a, c, whatever, I'm talking about a is the number in front of x squared, b is the number in front of x to the first power, and c is the constant term, the regular old number over there by itself. So just know, when I use b and a and c, that's what I'm talking about. This formula just happens not to use c. Alright, so axis of symmetry. While I'm thinking about it, let's do a quick example of what I mean when I say find the axis of symmetry. In other words, how to use this formula. Alright, so the top says opposite of b. You can literally show your work by just saying negative b. So negative, and we plug in a negative 4 because b is negative 4. So negative negative 4. All over 2 times a. Well, a is 3, so 2 times 3. Now, yes, you know the top. A negative negative is a positive, so that's positive 4 over 6, which simplifies to 2/3. So in this quick example I made, yeah, it was an ugly fraction, but the axis of symmetry is at x equals 2/3. That would be the axis of symmetry. Meaning if you were to graph this, and that's 1, 2, 3, well, 2/3 is right here. So this vertical line, where I just put a dotted line, that would be the center of our parabola. That was a quick ugly sketch, it didn't really match up, but that would be the axis of symmetry. That's a quick way to find it. Now let's talk about the vertex. The vertex is on the axis of symmetry. I know it's not a corner or a vertice like a shape would have, but a vertex is the maximum or the minimum value of the parabola. Notice, only parabolas that open downwards have a maximum, kind of like a mountain peak. Only parabolas that open upwards have a minimum, like the bottom of the valley. So when I say maximum, we're talking about downward opening parabolas. When I say minimum, we're talking upward opening. So just keep that in mind. Anyway, you can find the vertex by using the axis of symmetry formula we just said. Using that axis of symmetry formula, that tells you the x-coordinate. In that last example, it was 2/3. But to make our life easy, let's pretend it was 2. Let's say when we did this formula, we got x equals 2, for simple math, just to make a point. You would go back and you would take that 2 and plug it in for x. So 2 squared is 4, 3 times 4 is 12, negative 4 times 2 is negative 8, so we have 12 minus 8 is 4, plus 5 is 9. So altogether we would find out y equals 9. When x is 2, y is 9. That would tell us, if we were to actually do this, our ordered pair of our parabola would be 2, 9. Our ordered pair of our vertex of our parabola is 2, 9. So let's recap that real fast in case that got confusing. Axis of symmetry is how to find the vertical line that runs down the middle of your parabola. Your vertex is in the middle of the parabola, so it will always be on your axis of symmetry. You can find the vertex by using the same formula for the axis of symmetry to get the x-coordinate of your ordered pair of your vertex, and then plug that back in to get your 9. Now, I pretended like it gave us an easy number, like a 2, just to make a point with it, but that's what I mean by finding the vertex. So if you're given the vertex, you already know the axis of symmetry. In this example, it would be 2, x equals 2, the vertical line that runs through x equals 2. This will get much easier with practice, I promise. Last 2 definitions, I promise. Then we're going to get into some graphing. Now, hopefully this page looks like review, but I want to make sure we're clear because you will have questions where they're going to ask you, hey, graph this, and then state the domain and range. The domain is the x values that the graph spans across. So as a review, we used to recite these last year. The x values are your input. They're also your independent variable, which is the one you choose. They're your domain, and they're the values that measure left and right. So all of these things mean the same thing. The range is just the opposite of all of those. The range is the y values the graph spans across, which it's the output. It's the dependent variable, the one that you do not choose. It is the range. It is the up and down measuring variable on the graph. So keep that in mind. Now, the good news is one of these is always the same, basically. All parabolas, in case I don't think I made it clear earlier, all parabolas are like the U shape, But you noticed I drew arrows on the ends of all of them. That's for a reason. That's because technically parabolas go on forever, meaning they keep opening up wider and wider and wider and wider. They keep going, so essentially they keep going outwards. So eventually they go everywhere. They go from negative infinity to positive infinity. So the good news is when someone asks you for the domain of a parabola, unless it's some complicated one with restraints in Algebra 2, which we're not talking about, you're going to say the domain is all real numbers. So the good news is, for each of the questions I ask, when I say, hey, what's the domain? You're going to say all real numbers. That's because that parabola goes, that one was kind of ugly, this parabola spans everywhere to the left. Doesn't curve like that, but it reaches. And this one spans to the right, so it's all values, so all real numbers. The range, however, is the one that you have to pay attention to. So, and I will do examples of it, but I'm going to give you a rough sketch real fast. If I gave you a parabola, and this is its vertex, and let's say that vertex is at y equals 1. So it's up-down value. If I said what is the range, what you would tell me is you would say, okay, the range is all y values such that, fancy word for just y is greater than, it doesn't mean y is greater than, I gave that away, but it's basically, you notice your parabola goes upwards. Its minimum value is x equals 1. It includes 1, so or equal to, but it's all the y values greater than 1. Because remember, y measures up and down. So the parabola is going upwards, and remember it goes on forever, which got little arrows on the end. So this is telling you the range is all values greater than y. That's what that means. So now this really is the end of the notes after this. Now we're just going to be doing examples. But just to recap these steps to make sure we're clear how to graph parabolas. This is basically everything we've already said, but now we're going to put it together in a list, and then we're going to do it. Then I'll stop going on without giving you more examples. Okay, you're going to start by finding the vertex. Start by using the axis of symmetry formula to find the x-coordinate, plug it back in to get the y-coordinate, but start by finding the vertex. Then you're going to make an input-output table, but you're going to pick values from both sides of the vertex. Remember, the vertex, like if that was my vertex, is a reflection of the left side and the right side. So the left side and the right side should be the same thing, but just to make sure you know which way it curves, pick values from both sides. That way you know if it opens upwards or downwards from the vertex. Now, 5 points is enough for you to choose. So you would pick like 2 numbers on both sides. So counting your vertex, 2 numbers on both sides, that would be 5 numbers for your x's. After that, you're going to graph those ordered pairs and draw a smooth curve that goes through them. Now, if it just says graph, you're done at that point. But if it says solve, meaning what are the x-intercepts, you're going to look at your graph and try to look to see where the graph crosses the x-axis. So let's do this. Let's finally do some examples. First example. Your job is to graph x squared minus 4 and state the domain and range. Sometimes it'll also say y equals x squared minus 4 because technically it's your output equals something being done to your input. So in order to do this, let's start by finding the vertex. It helps to think of this in standard form. You notice that the x term is missing, the x to the 1 power. So I'm going to say you can also phrase this as something slightly different. You can phrase this as 1x squared, but the x to the 1 power is gone. Therefore, its coefficient must have been a 0, because when you multiply by 0, it disappears. So 1x squared plus 0x minus 4. So all I did was this missing, right, it's normally in the middle term, the x term or the bx term. If it's gone, that means b must have been 0. So to help you know that b is 0, I just did a visual. Now we can use the formula to find the vertex. So it's the opposite of b over 2a. Well, the opposite of b is 0, so that's negative 0, but it's still going to be 0 over 2 times a. Well, a is 1. So now that's going to give us 0 over 2, which is just 0. So that tells us the axis of symmetry, or our vertex, is going to be located at x equals 0. Now that's the value we put in the middle of our input-output table. Allow me to show you what I mean. These should look familiar. This is an input-output table. Now, we just said the vertex was at 0, or the axis of symmetry, so let's put that in the middle. I now want you to choose 2 values on both sides of that. So, for example, negative 2, negative 1, and then 1 and positive 2. Pick things that are equally far from the middle on both sides. So if you're going to go 1 less, 2 less and on one side, go 1 more, 2 more on the other side. It doesn't have to be the ones right next to it. It could have been anything. But pick numbers that are easy to calculate. Make your life easy. Those are the numbers you plug in for x. So notice, for all of them, you're going to plug in for x, so you have a blank parenthesis there. So just go ahead and plug all of them in. Now you just follow the order of operations to calculate each of those to get your y value. Well, negative 2 squared is 4, positive 4. 4 minus 4 is 0. So our first point is located at negative 2 comma 0, and so on and so forth. Negative 1 squared is positive 1. 1 minus 4 is negative 3. Plug in a 0. 0 squared is 0. 0 minus 4 is negative 4. So that's our vertex is located at 0 comma negative 4. Now 1 squared is 1. 1 minus 4 is negative 3. Oh look, that's a repeat of that one. That should happen if this value is equally distant from the vertex as the other value on the other side. That should happen. 2 squared is 4. 4 minus 4 is 0. Oh, and I forgot the last one. Now you have all your points. Graph these points on a graph. So I just graphed the first two, but keep working your way down and graphing each of them. Now you'll notice we're about to graph our vertex, so at this point it should start to curve backwards, and it does. 1, negative 3, 2 comma 0. So you've now graphed the points to give you enough guidance to draw your parabola. So at this stage, you can try to draw a gentle curve that goes through each of these points. Make an effort to make it as symmetrical as you can, and there you go. It's basically kind of like sketching. You have drawn the graph of this parabola. This should feel familiar. This should feel old school. Back when we were doing lines. You make an input-output table. That was the easy way. That was the original, longer way we learned how to graph lines. Okay, so now the vertex is 0, negative 4. If they ask you for the vertex, it's 0, negative 4. If they ask you for the solutions, name these two values. That would be x equals negative 2. The other one is x equals positive 2. They won't always be the opposites like that, because what if the parabola was over here? It would be this value and this value. They're not always going to be opposites like that, so don't expect that. So you found if they ask you for the solutions, those are the solutions. If they ask you for the domain, remember, the domain is just all real numbers, because this parabola extends everywhere, left and right. So the domain is all real numbers. Some of you might remember the fancy symbol for that is that fancy looking R. That means all real numbers. Now, the range is not all numbers, positive, negative, infinity. The range only goes down to negative 4, but then it's everything above that. So the range is everything above negative 4, including negative 4. So that's one way to write your range. Sometimes you might see it written this way. Negative 4 and then positive infinity. Sometimes it's written this way. We'll talk more about how that second way of writing it, but focus on this first way for now. Just understand it's everything greater than negative 4, including negative 4. Let's do one more example. We won't spend as much time on this next one. So feel free to try this one yourself first. Hit pause and give it a shot. Graph and solve this one. In other words, find the vertex first, make your table of values, graph your table of values, and then talk about all the things we talked about in the last one. As a side note, you'll notice it's set equal to 0, because when you solve, meaning you're finding the x-intercepts, that's where y equals 0. You can imagine a y is there. So it's just like what we talked about when we were factoring polynomials. In other words, what would make the function equal 0? What would make y equal 0? Alright, so let's first use the axis of symmetry formula to find the x value of the vertex. A is 1, B is 7, and C is 12, and my dog is squeaking her toy. Get the toy, take it! Well, Mrs. Phelps has tackled the toy away from Chloe, so we're safe now from the squeaking toy. Anyway, now that you know what A, B, and C are, go ahead and plug those into the formula. So we find out that the x-coordinate of our vertex, or our axis of symmetry, is that x equals negative 3.5, or negative 3.5. So now that's the value we're going to put in the middle of our graph, of our input-output table. So negative 3.5 is in the middle of our input-output table of our values. I recommend you choose values on both sides of it, equally distant from it, to make your life easy. So let's say negative 4 and negative 5. Notice, you don't have to keep choosing fractions. That would make your life harder. Choose things that are easy to calculate. So negative 3 and negative 2 are on this side. So now those are the values you're going to plug in. Feel free to jump ahead and do that if you haven't done so already. Feel free to get your templates ready, and I'll plug them all in and evaluate. I hope that you use negative 3.5 just so it's easier to put in the calculator. You don't have to worry about your fraction skills right now. So if you evaluate each of these are the values you get. These are the values you're going to graph. Feel free to estimate when you graph this, just get it close. So now go graph these, and then draw your curve, and then answer everything we did before, and we're all done. Before I move on, I want to caution you, common mistake students make is they forget that a negative squared is a positive. So don't get freaked out by all the negatives or the fractions. A negative squared is a positive. Okay, these are the points we need to graph. Notice, one of the advantages of picking numbers that are equally distant on both sides of your axis of symmetry or your vertex is that these values will be the same. It's a good way to check yourself, and so it makes that nice. So let's go ahead and graph these dots, and we'll draw a curve. When graphing -3.5, just remember that's between -3 and -4, so that's right here in the middle. But it says -1/4, so that's going to be a little below 0, about 1/4 of the way down. So it's going to be about right there. And then now you go ahead and draw the rest of your dots. Now that you have your dots, do your best to draw a gentle curve that goes through them. Hopefully yours came out more attractive than mine. Try to make it a smooth curve. It shouldn't have any straight lines in it, although mine looks like it might. And then you've now graphed your parabola. So now, let's answer some of the things we said before. For example, if we were to say, what are the solutions? What are the x-intercepts? Well, visually, they're right there. That's -3 and -4. But if you're not sure, look at your input-output table. If usually, it's not usually, but usually you'll find it this way. Where's y equaling 0? And you notice it's happening at -3 and -4. So those are your solutions. You would say, my solutions are -4 and -3. Now, if it says, what is the domain? The domain is all real numbers. So domain is all real numbers. But if they ask for the range it's a minimum value in this case. The vertex is a minimum. It starts at -1/4, but it's everything bigger than that. So greater than or equal to -1/4. So you're done graphing this quadratic equation. Now, I'm going to make that our last example, but before we finish, I am going to give you a quick sense of wisdom, perspective. The graphing technique of solving quadratic equations only is a precise way and only works when the solutions are pretty numbers, meaning numbers that are easily identified, meaning integers. These are also the same types of quadratics that you most likely have the skill to factor on your own, and you could have solved them by factoring, which is why we spent so much time factoring last chapter. So the issue with the graphing technique is it doesn't help you pinpoint when let's say the parabola crosses in between like that. It's hard to pinpoint what that value is. You could guess and check by plugging in this one right here. Looks like it's about 1.7 or something. You could guess and check by plugging 1.7 in for x, 1.7, 1.7, and see if that gives you 0 for y, and get as close as you can, but you'll technically be guessing and checking and narrowing it down. It's not a precise way. It works. You could do it that way, but it's not super precise. We are going to learn a way that always works for any quadratic, like what I just said with those ugly answers especially, and we're going to talk about that later this chapter. It's called the quadratic formula. Don't stress about it now. It's not a big deal. We'll get to it. So for the sake of graphing, it helps for pretty ones, but it helps you visualize. But when I say pretty, I mean ones that have integer solutions, meaning regular, whole number, positive or negative, x-intercepts. Alright guys, this was the graphing method. Make sure your notes are neat and organized. Come to class and we'll pick apart a bunch more problems together. Take care.